நீங்க வச்ச ஃபைல் ஏடிசார் ஒரு ஃபைல் வச்சுருப்பாங்கல்ல, அந்த ஃபைல் வாங்கிக்கிறேன். பிரின்சிபல் புதுசா மீட் பண்றதுக்கு 2014
ராதலட்சுமி மேம்.
சார்
ஸ்டார்ட் பண்ணலாமா எப்படி?
ஓகே சார், ஸ்டார்ட் பண்ணலாமா சார்? 31 தான் ஓகேவா சார்? ஸ்டார்ட் பண்ணுவோம் சார்.
பண்ணுவோம்.
ஓகே சார். So good afternoon to all. Welcome you. The AICT sponsored Training and Learning Academy sponsors 6 days online faculty development program on AI assisted integration of renewable energy sources into EV charging networks from 18/8/25 to 23/8/25. Today is the last day. So today we have two wonderful sessions from eminent persons, resource persons. So in first session, we have a resource person as our Associate Director, Dr. Nagarajan sir. Actually, Dr. Nagarajan sir working as the Associate Director of Solamalai College of Engineering, Madurai. He worked as a principal at Surendra Institute of Engineering and Technology, Siliguri, Darjeeling, West Bengal for past 3 years. And also he worked as a professor and head of the Department of EEE at Jerusalem College of Engineering, Chennai. He had more than 25 teaching experience in a reputed institution. He completed a PhD degree in Anna University, Chennai in 2014. He published more than 25 journals in international and national level and also presented more than 35 papers in international conferences. Dr. Nagarajan sir has been instrumental in advancing academic strategies aligned with faculty and university goals. His initiatives fostered effective departmental management, enhanced communication with the staff and students, and optimized collaboration opportunities beyond departmental and faculty boundaries. Under his leadership, the faculty teams achieved significant milestones such as NBA and NAC accreditations and autonomous status, earning commendations from accrediting bodies. Notably, during his tenure at Solamalai College of Engineering, the institutions attained NAC accreditation with an impressive A grade 3.2154 and was granted autonomous status for 10 years starting in 2024. Under his guidance, Solamalai has obtained AICT Idea Lab initiative funding to set up a laboratory. Dr. Nagarajan sir is a recognized supervisor for MS PhD programs at Anna University with his research interest spanning electrical machines and drives, power electronics, renewable energy, and power system. Currently, he guides 3 research scholars and has successfully supervised 50 undergraduate and 15 postgraduate projects. Dr. Nagarajan sir is a fellow of IEI and a life member of IET, IEAE, and ISTE. He has actively organized numerous faculty development and training programs sponsored by Anna University and ISTE. An accomplished scholar, he has published over 54 papers in both international journals and also conferences. So we have the wonderful resource person for our session. Welcome you, sir.
Thank you, ma'am. Thank you so much for the nice introduction.
Okay, sir.
Is my voice audible?
Yes, sir. Yes, sir. Audible, sir.
Thank you. Before moving on to the today's topic, let me thank ATAL Academy for giving grant of 1 lakh rupee for conducting 1 week FTTP on this chosen topic, AI assisted EV vehicle connected to the networking. And nowadays, organizing 1 week program is not an easy task in both both in physical mode as well as in online mode. I must thank all the participants, faculty members from various engineering colleges for your constant support to make this event a grand success. Today, we are going to have a final day, and after the session, we are going to have a valedictory session. I must thank my coordinator, Dr. Radha Lakshmi, for her continuous support in smooth conduct of this 6 days FTTP, as well as my fellow faculty members from Solamalai College of Engineering and from other institutions who have accepted our invitation to be the resource person for this wonderful ATAL Academy sponsored faculty development program. With that small note, I will straight away move on to the today's session. The chosen topic is an overview of sustainable pathway for the global energy transition. This is supposed to be the inaugural session of this FTTP, because I am going to talk about the purpose of going for renewable energy and purpose of going for EV vehicle. I am not going in detail about the technical aspects. Therefore, this session will be more about, the requirement of the sustainable energy in the near future. And I have given 2 pictures in my title slide. The top portion, you have forest, the greeneries. The next one, the down one, will be the latest technologies, green energy related tools like vehicles and wind power plant and other accessories I have mentioned. So actually we are expecting this, but we could not able to protect our nature. That's why we are in need of renewable energy, green energy to protect our environment. And it is our responsibility to give safer environment to the future generation. So with that small intro, I will move on to the today's topic. Whenever we talk about green energy, whenever we talk about environmental aspect, everybody is talking about global warming. You might be coming across this word in your school days. See, 20, 30 years we were discussing about global warming, but without knowing the severity of global warming in the near future. So what do you mean by global warming? The name itself is very clear. Globe is warming, right? The temperature of the earth is keep on increasing. As per the definition, the average temperature rise of last 100 years is more than 1 degree. Then you can call it as your globe is warming. And if you take the latest research data, according to the latest research data, the temperature rise of last 20 years itself is more than 1 degree. So we are in high danger state, where globe is keep on increasing. The temperature of the globe is keep on increasing. If you look at the main reason for the temperature rise, is the everybody is talking about the one word that is called carbon. See, why we are facing this problem? See, because of carbon, there is a ring formed around the earth, so it does not allow the heat transmitted from the sun surface. That is the main problem. This is one aspect. Because of the industrialization, because of the development, your industries are emitting carbon, your transport sectors are emitting carbon. Then from power stations, you are getting carbon emission. Not only that, and parallelly for urbanization, we are gradually, reducing the area of forest. We are keep on cutting down the trees. That will affect accumulation of more carbon into the environment. One side, we are emitting more carbon. Other side, we are damaging the natural resources which will consume carbon from the atmosphere. So trees are the natural resource which can inhale carbon, and it can exhale oxygen for the human being. That is the new natural circulation of carbon dioxide in oxygen cycle. But we are damaging the forest, as well as because of the industrialization, because of the industry 4.0, 5.0, we are keep on producing more carbon to the environment. That is the root cause for more carbon emitted into the environment. That leads to temperature rise of the earth. That is the main cause for the today's environmental impact. So without addressing this, it is unnecessary to talking about other development aspects to promote green vehicle or green energy, or whatever the name we call it as, to protect the environment for the future generation. So in this slide, I have given the percentage of carbon emission from different countries. If you look at the graph, China will be the maximum contributor. So with the 27.2% contribution is from China, and followed by United States with 14.6%. And India standing at third position. We are responsible for 6.8%, and rest of the world contributing 15.8%. So with that constant, there is a popular conference that is called Paris Climate Change Conference. In that conference, they have invited around 192 countries, representatives from 192 countries, to discuss about the how to restrict further carbon emission into the environment. So in that conference, all the developed nation as well as developing nations, they have come to a conclusion that the two important area we have to focus on to restrict and to limit the further carbon emission into the environment. See, if you look at that graph, you will get a clear-cut idea about the carbon contribution from various sectors. And the bottom one represents electricity and heat. So the 50 to 60% carbon emission is from power sector, because thermal power plant contributing more carbon emission into the environment. Then followed by we have manufacturing industry, energy industry. So I am in my presentation, I am going to concentrate on these two aspects. One is electricity, then another one is the transport sector. So in the Paris conference also, they have taken a conclusion that to limit further carbon emission into the environment, we have to stop generating electricity from thermal power plant. That is one resolution. The second one, instead of using the third important contributor for carbon emission will be from transport sector. Therefore, everybody has agreed to replace conventional vehicle, that is petrol, diesel vehicle by EV vehicle. So these two are the major resolution they have taken during that very popular Paris agreement. And especially India has agreed, I have given in the bottom, India has agreed to limit carbon emission by 33% to 35% by or before 2030 when compared to this statistics data has been given based on 2005 level, because this resolution has been taken during 2005 Paris conference. Therefore, based on that data, every country has given some percentage as an earmarked percentage to limit their carbon emission. So we have signed an agreement to reduce 33 to 35%, let's say 40%, because we have to have some buffer limit. So we are working on to reduce 40% of the carbon emission when compared to 2005. This has to be achieved by 2030 or on or before 2030. So in that context, slowly they are launching alternate option for power generation, that is replacing thermal power plant by either solar power plant, wind power plant, or using other natural resources. People are thinking about how to generate power. A lot of research is happening. So that's why I used to inform my student as well as my fellow faculty member that there will be a bright chances for electrical engineering students near future, especially 2027, they will be getting a lot of opportunities both in power sector as well as in transport sectors, because government is investing huge amount of money for the installation of solar power plant, wind power plant. They wanted to slowly replace thermal power plants. Similarly, they wanted to replace fossil fuel vehicle like petrol vehicle, diesel vehicle by EV vehicle. That's why I used to inform all my fellow members that don't go for, if anybody is having in their mind to buy any four-wheelers, my suggestion would be don't go for any purchase for next to 2 years, because government is going to come out with new policies for EV vehicle, and you'll be getting a lot of subsidies the near future, especially in 2027. Therefore, you please postpone purchase of any four-wheelers for another 2 years time. That is, don't buy any vehicle for 2026 and 2027. So therefore, you will be getting a lot of subsidies, lot of offers during 2027. And however, you will not be permitted to operate your vehicle after 2030. That was the silent decision taken, silent decision, and a lot of discussion happening with the government official. But in our country with the huge population, I don't think so. It is very difficult to completely eradicate petrol vehicle and diesel vehicle by 2030. Slowly, they will come out with different policies. Initially, they will ask us to go for hybrid vehicle where you can have both IC engines and electric motors, and slowly, they will replace IC engines by EV vehicle. That is how government has proposed to launch alternate energy in terms of power generation and in terms of transport sector. That is going to be the future. Therefore, you please advise all our students to do some certification course on EV vehicle, as well as especially they can concentrate on solar power generation, wind power generation. So please motivate the students to take up any project which is relevant to either renewable energy or which is relevant to EV vehicle. Especially lot of research work is happening with battery technology, because the problem of not promoting EV vehicle in our country is the initial investment cost for battery technology and charging infrastructure. So once we come out with the proper solution for charging infrastructure of battery, as well as the lifetime of the battery, then we will be having better affordable price, on-road price for EV vehicle. Soon we will achieve that target, and hopefully by 2027 we will be having green environment all over India. So according to NASA report, already I have given this data because now global warming is the main reason for moving on to renewable energy, green energy, and green vehicle. As I said earlier, if last 100 years average temperature rise is more than 1, then you can call it as globe is warming. Already our globe is warming because the recent past 20 years, the average of the temperature rise already crossed 1 degree. Therefore, we are in high danger. It is in high alert. So we don't have any other option. We have to go for renewable energy for power generation, as well as green vehicle for transport sector. So why alone electrical engineers are talking about this carbon emission? Because everybody was talking about industries are the main root cause for this carbon emission. But later on, people come to know that power plant, especially thermal power plant and transport sectors are more contributors for this carbon emission. So if you take thermal power plant and if you take transport sector, is it only relevant to electrical engineer? No, everybody, every citizen are responsible for this environmental impact. Every citizens are responsible for this carbon emission. So in order to justify that the impact from each citizen, I have given you small statistical data. As per the Tangentco website, right now, India is generating 65 to 75% of the electricity is from thermal power plant, right? And if you look at the total emission, CO2 emission from thermal power plant, as per the statistical data, to generate 1 unit of electricity, that is nothing but 1000 watts per hour, right? 1 kilowatt. 1 kilowatt per hour. So that is exactly 0.94 kg of carbon dioxide. Let us say for the sake of calculation, I will take to generate 1 unit of electricity, thermal power plant will emit 1 kg of carbon. So to generate 1 unit of electricity, our thermal power plant will emit 1 kg of carbon dioxide. So if you look at total electricity generation of our country, it is around 1,433 terawatt hour. This is based on 2016-17 data. Now it has gone up to 1,600 terawatt hour, but I have done the calculation based on the data available in the government website. So it is 1,433 terawatt hour. 1 terawatt hour is equal to 10 to the power of 12, right? Just imagine how many units. This is the total electricity generation. And I have divided this total electricity generation by the total population of our country. Our population is somewhere around 130 crore to 135 crore of people. Therefore, if you divide total electricity generation of country by total population, I'll be getting total consumption per capita. That is how much of unit is consumed by every citizen. So it comes around 1,122 kilowatt hour. 1,122 kilowatt hour. That is 1,122 units. Every citizen are responsible for 1,122 units per year. And out of this 1,122, out of this, in the previous slide I have mentioned 65 to 75% of the, 65% to 75% of the energy are generated through thermal. So we are relying on thermal power plant, especially in our country. We are depending on thermal power plant. Through thermal power plant, if you want to generate 1 unit of electricity, for the calculation purpose, I have told 1 unit will emit 1 kg of carbon dioxide into the environment. Therefore, I have done a small calculation. So total power consumption, electricity consumption per person per year equal to 1,122. Out of this, as I said earlier, 65 to 75% of the energy are through thermal power plants. I have taken the average, therefore 70%. So 0.71 kg. Here I have taken exact emission. It is 0.94 kg of carbon dioxide. Therefore, total carbon dioxide emission, total carbon dioxide emitted to the environment will be 673 kg. So every individual, it is not only with the electrical engineer, it is not only with industry. Each and every one of you is responsible for 673 kg carbon. So natural away, we have alternate resources to neutralize the man-made disasters. So we have a tree. Tree can inhale approximately 20 kg of carbon dioxide per year. And these trees will inhale carbon dioxide and exhale oxygen to the environment. So we have a natural, excuse me. So each mature tree can inhale 20 kg of carbon dioxide in a year, and this will release a good amount of oxygen for a family of 4 members. So like that, if you want to have to neutralize the previous slide I have mentioned, everybody is responsible for the emission of 673 kg carbon dioxide into the environment, right? Therefore, how many trees are required to neutralize this emission? So as per the calculation, I am getting 33 trees are required. 33 trees are required to neutralize 673 kg carbon dioxide. Let us have a small data, statistical data regarding the number of trees available in our country. So I have taken total population of our country is 126 crore, but now it is 132 plus crores. 1.32 billion people are available in our country. This is based on 2016-17 statistical data. And if you divide total number of, if you look at the tree population, it is somewhere around 35 billion trees. So if you divide total tree population by population, you'll be getting 28 trees. So right now, we have 28 trees in our country for each citizen. But as per my calculation, to neutralize the 673 kg of carbon emitted due to every individual, we need 33 trees, but right now we have only 28 trees. Therefore, the shortage will be 5 trees. So in that context, only AICTE has come out with 5 years before. They have come out, they have initiated one campaign called One Tree, One Student, One Tree Initiative. And in every campuses, all the students were motivated to, go for plantation, sampling plantation during every national importance day. And they were asked to give their name for the particular tree so that they will be responsible for, growing that sampling into a good amount, a good position. So that's how AICTE has come out with this kind of good initiative. And our former president, People's President, Dr. APJ Abdul Kalam also has taken personal interest to promote this culture among all the citizens. And he has chosen a few actors, especially Vivek, our former, late comedy actor. Vivek was actively involved with the tree plantation. And one side, we are taking enough measures to increase the population of tree. So we have only two options. We are keep on adding more carbon dioxide into the environment, right? Because of that, our environment is completely, affected by the climate change. So to protect the environment, one side we have to reduce the further carbon emission. That is one aspect. How to reduce further carbon emission into the environment? For that, we have alternate ideas by replacing thermal power plant by solar power plant, replacing thermal power plant by wind power plant, and we can go for alternate resources to generate electricity. That is one aspect. Then the second aspect, the transport sectors try to replace fossil fuel vehicle, petrol vehicle, diesel vehicle by electrical vehicle. That's how we can reduce the further carbon emission into the environment. The second aspect would be increasing the tree population, but that would take time, right? It is not easy to increase the population of tree within short span of time. So it will take time. So we are taking both measures. One side, we are concentrating on improving the tree plantation. Another side, we are concentrating on going for alternate energy resources, so that parallelly we are doing reducing the carbon emission, further carbon emission into the environment. On the other side, we are increasing the population of trees so that the tree can inhale more carbon dioxide available in the environment. So that way we can neutralize the effect of carbon emission into the environment. So I have given the solution. Already we have discussed. Every person has to plant 5 trees to avoid further temperature rise in the Earth's surface, or we have to increase RE generation and reduce thermal power generation. So we have to go for solar energy, wind energy, because 20, 30 years before, we totally rely on thermal energy. Now, nearly 40 to 45% of the total energy requirement is coming from renewable energy sources. We are the second largest renewable energy producers next to China. Germany also doing a lot of research work with respect to renewable energy source, and we are also doing a lot of changes with respect to power generation and with respect to transport sector to protect the environment against further carbon emission. So with that, I'll move on to the purpose of going for EV vehicle. And we have a few challenges to move on from conventional energy to solar energy, conventional vehicle to EV vehicle. I have listed out a few points. The unprecedented growth and cost improvement in RE resources, because in thermal we can have a constant price, whereas for RE resources the prices are not stable. Sometimes it will be low, sometimes it will be high, because when you get a lot of power from the renewable, then the cost will come down. If you have a shortage of power, then the cost will go up. So now we don't have a standard tariff plan for renewable energy. That is the biggest challenge right now we are facing. And a lot of improvements, a lot of research is going on in implementing new technologies to harvest more power from solar as well as from the wind. So technologies are keep on changing. If you invest on today's technology, then after 5 years, then you have to replace the technology by the latest one. That's how the technologies are rapidly changing day by day, and growing instability in fossil fuel supply and prices. The main purpose of going, because we are not relying on the fossil fuel. The current scenario. Now we are purchasing crude oil from Russia. We could not able to import from Arabian's country due to a lot of political reasons. You might have come across in latest news. America is imposing huge tariff to India to procure crude oil from Russia, and growing support to RE from governments and investors, and electricity generation by new and different entities. These are some of the challenges. Renewable purchase, sometimes it will be very low. As I said earlier, if you have more power generation from renewable, then the price will come down. If you have a very low, then the price will go up. And the finance part is not stable, so it is very difficult to predict the tariff of RE sources. And government policy is also not stable. They are also keep on changing, so that affects the economy of the country as well as the growth of the RE sector. So now we are in the transition period. So during transition period, this kind of problems are quite natural. Soon we'll get the solution and constant guidelines to properly implement both in energy sector as well as in the transport sectors. Therefore, we will be having a bright future both in RE energy sector as well as in the EV transport sectors for electrical engineers. So one side we are talking about thermal energy, other side we are talking about green energy, clean energy. But if you look at the ground reality of the country, as I said, it is despite the rapid developments in green sector, green energy, still 1.1 billion people around the world still living without access to any form of electricity. One side we are talking about we have to replace thermal by green energy, solar, wind. We are talking about latest technology, but still there are places where they are not able to access to any form of electricity. So that area can be promoted with solar, wind. You know, everywhere we will be having solar power, wind power. So maybe in near future, these problems will be sorted out with the support of United Nations. Hopefully, we will achieve 100% electricity access in the near future. And we work on initiatives that use sustainable, because nowadays everybody is talking about sustainable energy. And in that contest, you know, United Nations also, they have come out with different sustainable goals. So in my last slide also, I am going to talk about sustainable goals. We will discuss later about the sustainable, because, you know, everybody is looking for sustainable growth, sustainable development for the better future. And innovation in technological solution, business models, partnerships, and knowledge generation remain the cornerstones of our action research. Hopefully, these problems will be addressed in the near future. Our work focuses on understanding the future demand for resources and promotion pathways for resource efficiency, waste management, and circular economy. All of our efforts continues to inform policymakers about solutions which need to be scaled up to decouple economic growth from environmental impacts. So this is the final one. We promote sustainability in the urban context through developing a wide range of solutions for green buildings. Nowadays we are talking about green buildings. Even in our class also, I used to address to all the students that in future we are going to have zero waste, zero electricity house. That is the concept. That is called smart house. In smart house, you will not have any wastages, zero wastage, and you will not depend on any electricity from the grid. That is how it is called zero waste, zero electricity house. I name it as smart house. So we are slowly moving on to smart house, smart buildings, green buildings, sustainable mobility, and planning and governance of low carbon. Everything is towards low carbon and to protect the environment and to limit the further temperature rise. And we wanted to have safer environment for our future generation. So next we'll move on to the today's core topic, electric vehicle. Why electric vehicle? Are we really going for green vehicle? If you look at the status of Delhi, Delhi is the highly polluted city in our country. So in Delhi, government has given GO, that is government order, that you cannot, you cannot drive vehicle without 4-seat capacity. If anybody drive vehicle with only single person, you'll be fined immediately, because their air pollution already reaches the maximum limit. Sometimes, government is declaring holiday to limit the further carbon emission into the environment. They are instructing both government sectors and private sectors to declare work from home, mandatory work from home option. If they violate, they will be fined. And some of the days government is giving circular that aged people and those who are having chronic disease, they are not advised to come out based on the the status of the air pollution. So they are measuring the air pollution index. Accordingly, they are giving orders time to time to guide the elderly people and those who are suffered with chronic disease. That is the standing example. One standing example, if you don't address carbon emission into the environment. So we have a standing example in front of all of us. Delhi is the first city affected by carbon emission, right? So therefore, it is the high time to promote conventional vehicle by EV vehicle. But if you look at the current scenario, are we really going for green vehicle? In the bottom figure, you are getting clear-cut indication that the black color indicates the fuels are either petrol and diesel, and you are getting carbon emission from this vehicle. The second figure, you have a green vehicle. But in the current scenario, unless you get power for this electric vehicle from renewable, then you cannot call it as it is green vehicle. You can call it as EV vehicle because you are using electric motor. But you cannot call it as a green vehicle unless you get power. Unless you get power for electric vehicle from green energy, from renewable energy, you cannot call it as a green vehicle. We don't want e-vehicle, we want green vehicle. That is the our need of the hour. But the people are not understanding the purpose of going for e-vehicle. Everybody is talking about simply replacing petrol and diesel. We will be getting green vehicle. Not like that. Unless you get the power from renewable energy, there is no point in migrating from fossil fuel to e-vehicle. Hopefully, lot of research work is going on. Even while driving, you can able to charge your battery. Your entire panel, entire body will be covered with the panel. So a lot of research work is happening. But only thing, it affects the outlook of the vehicle. So for that, they are going for different designs so that it will not affect the outlook of the vehicle. So the entire body of the vehicle will be made up of solar panel in near future, so that it can able to generate power required by the battery while driving the vehicle itself. You need not depending on any external power sources. That is one way to achieve green vehicle. So that is the simplest solution. You can take your vehicle for longer distance while running itself. You can able to charge. That will reduce the size of the battery. That will reduce the investment for the battery. Right now, the biggest problem with EV vehicle is the investment cost for battery. So we need huge battery to take the vehicle into long distance travel. Now, with the current capacity, EV vehicle was suitable only for city limit. You cannot take the vehicle outside the city because we don't have proper charging infrastructure. So it is very difficult to charge your battery after 200 kilometers, 300 kilometers. So based on the currently available capacity, you can drive the vehicle up to 200 to 300 kilometers with single charge. And again, you have to charge the vehicle. For that, you need to wait for half an hour to 1 hour, depending upon the type of charging you are using and the quality of the battery and other brand which we are purchasing. So a lot of other practical problems we are facing. I think in many sessions we were discussed about different types of electric vehicles. Anyhow, again I am touch upon the basic components. The main advantage of e-vehicles, only it has leisure parts, right? We have a battery and we have motors. Then you have a controller sections, which will convert your DC energy into suitable AC for the to drive the motor for electric vehicle. And we have different types. Battery electric vehicle, power source is purely from battery. The second one is the hybrid electric vehicle, where you have both IC engine and a battery source. That is why it is called hybrid electric vehicle. Then you have plug-in hybrid electric vehicle. Then the final one will be fuel cell electric vehicle. A lot of research work is happening with fuel cell and supercapacitor also. They are planning to have it for EV vehicle in near future. Let's see what will be the future of electric vehicle. But 100% I am sure that by 2027, if not 2027, by 2030, all vehicle on road will be EV vehicle, because that is the government policy. They are waiting for the next government. So maybe next government will announce the government policy regarding this promotion and implementation of EV vehicle. Some of the EV vehicle currently available in the market. This one is the Mahindra E20 Plus. It is a 4-seater electric hatchback electric vehicle. It has 280 ampere hour lithium ion battery. It can reach maximum speed of 85 km per hour. And with single full charge, it will take 6 to 7 hours. So that is the main problem. So every night you have to plug in your charger. Then morning you can take your vehicle for your office. So now this vehicle will be suitable only for office goers. You cannot take this vehicle for long drives. If you want to take this vehicle for long drive, then you need to increase the capacity of the battery. If you increase the capacity, then weight of the vehicle will increase, then cost of the vehicle will increase. That is not affordable for the medium class people, because this is a hatchback model. It is meant for middle class people, right? So you cannot further increase the capacity of the battery. Then it is impossible to sell this product in the market. We have to look at the cost of the product also before going for the capacity of the battery. The next one is the Mahindra E-Verito. Actually, it has 3 variants. Now the cost of the vehicle starting from 10 lakh. And the speed of the vehicle will go up to 110 kilometer. This is the latest model in the Mahindra. And Nissan is the most popular electric car, launched back in 2010. They have sold more than 2.8 lakh unit globally, and we can drive this car up to 300 kilometers. And the cost of the vehicle somewhere around 20 lakhs. That is the biggest problem, right? If you increase the capacity, then the cost of the vehicle will go up. And Nissan, this model will be very popular. and they have launched 2010, very popular in the on-road. Now we are all depending on only home charger. Even for two-wheeler and four-wheeler, we are using our own 3-point home plug point for charging the vehicle. This is the model by Tata. This is the high-speed vehicle, so it can reach up to 135 km/h. A very affordable car right now available in the market. It's priced around 8 lakhs to 10 lakhs. Maybe after budget, the price may come down, slightly come down. Let's see the price after budget. And this one will be Mahindra KUV 100 EV. This is priced around 7 to 9 lakhs. This is also a medium budget price. Like that, we have different models, and other speakers also spoken about different EV models available, and they have spoken about other solutions for battery charging, swapping of battery and replacing the battery. A lot of other mechanisms are under research. Hopefully, we may get a suitable solution in the near future. But according to the current scenario, what are the hurdles and what are the limitations right now we are facing with EV vehicle? I have listed down major hurdles with respect to EV vehicle. The first one will be purchase price, because if you go for normal fossil fuel vehicle, petrol or diesel, we can easily purchase medium level car, that is called hatchback car, up to 5 to 6 lakhs you can easily purchase. Whereas with the same model, same capacity, if it is EV, then you have to spend another 3 to 4 lakhs extra to get the vehicle. So the purchase price now in the current scenario, purchase price will be slightly higher than the conventional vehicle. So maybe when you go for mass production, and with the advancement of latest technology, we could able to sell EV vehicle with much cheaper price in the near future. That's why I always suggest not to buy any vehicle for next 2 years, because there will be a huge difference in the selling price after 2027. So you'll be getting much better price after 2027 in the transport market. Therefore, you postpone the purchase of vehicle for another 2 years time. The next one will be the charging time. Even if you take your petrol vehicle to a station, petrol station, the moment you see 2-3 people are standing in the queue, then we will immediately move on to the next petrol bunk, because we are not ready to wait even for 2 to 3 minutes to fill the tank. This is the human mindset. But if you have an EV vehicle, even there is no people in the charging station, then you have to spend minimum 30 minutes to charge the battery. So with advanced technology available right now in the market, you need minimum 20 to 25 minutes to charge your battery, which is highly, impossible, especially when you are moving on to office in the morning, and when you are coming back to home in the evening. You will not in the mood to wait for another 20-30 minutes, either in the forenoon or in the evening, to charge your vehicle. So either people mindset has to change, or we have to go for much better charging technology. I would always take the mobile charging as their reference. Or 10, 20 years before, to charge a mobile phone, you need to plug in the charger for more than 8 to 10 hours. Now with the fast charging, you could able to achieve full charge within 15 minutes, right? That is the development of the charging chargers. Likewise, a lot of research work is happening. Maybe in future, now it takes 20-25 minutes to charge the vehicle. Maybe it can reduce to 10 to 15 minutes. Maybe further it can reduce, or we may come with a suitable swapping model, so that without any delay, while going, you can able to replace the battery. But how far that option will be feasible, I am really doubtful at this present scenario. But we may not know in future anything can happen. Let's see suitable suitable fast charging technique or suitable model will be launched in the market, so that EV market will pick up in the transport sector. Next, infrastructure. The current scenario, we don't have proper charging infrastructure. It is very difficult to find out charging station for EV vehicle. So most of the cases, we have to depend on our own home electricity for charging the vehicle. It will take more time to charge the vehicle. Unless you have commercial charging unit, it will be very difficult to charge the vehicle with a short span of time. Hopefully, this will be addressed by government. It is not done by any individual. So we need the support from infrastructure, charging infrastructure from the government. I strongly believe that a lot of business opportunity, entrepreneurship opportunity available with respect to charging network in the near future. And vehicle range, again, this is the biggest problem. Right now, we are using medium capacity batteries for driving the vehicle. So it is more suitable only for city limit operation. You cannot take a vehicle for outside the city limit. Unless you increase the capacity of the vehicle, it is not advisable to take the vehicle outside the city limit. Maybe in future, with the support of government, infrastructure support, and with the suitable fast charging technology, we could able to achieve better range in the near future. And the biggest problem will be the battery, burning of battery, because the battery technology right now we are using is not reliable. If you operate your vehicle for a longer period, then this will heat up, and over the period, this may affect the lifetime of the battery. Sometimes it leads to fire accidents, and we have experienced a few fire accidents with respect to Tesla model. It has now come up in the newspaper and headlines, and now they have developed a battery management system. With the support of battery management system, we could able to manage health of the battery. We could able to manage thermal limit of the battery in a proper way. Therefore, the risk of the battery has been managed better with the support of battery management system. However, we are in need of proper charging infrastructure, as well as charging time. These two are the with respect to out of these 5 points, I would suggest the charging time and the charging infrastructures are the real hurdles for the growth of the e-mobility. For these two aspects, for infrastructure, government support is required, and with respect to charging time, technology support is required. Hopefully, we will achieve these two in the near future. And the entire world is talking about sustainable development goals. United Nations has announced 17 sustainable goals. This is apart from the today's presentation. This is my humble request to all the faculty members over here. You please talk about these sustainable goals when you have time in your class. You please put this slide and read out what are the various sustainable goals required. And whenever you send any proposals to funding agencies, please keep these points in your mind. Because always, when we write proposals, two aspects are very, very important. One is what problems we are going to consider. And the second one will be the solution for that problem. And the third one will be the technology which we have used to solve these things. So the title will be the key parameter for writing any proposal. So your title should give what problems you have considered and how you are going to give solution for that problem and what are the tools you are using. These 3 points should be either directly or indirectly reflected in your title, because most of the case, the initial screening will be done purely based on title. Whenever your proposals are not shortlisted, you please seriously review your title first. The first and foremost thing for getting our proposals shortlisted to give proper suitable title. Most of the time, we are spending our valuable time to write the aim, scope, and description about the problem, solution, various aspects we are giving our time, but we fail to spend enough time to give proper title. So hereafter, when you send any proposals, don't forget to address these 17 goals. And your title should address any one of these sustainable goals. Then only your project or your proposals will be shortlisted and will be considered for any funding options. So with that, once again, I thank all the participants for spending your valuable time with us for last 6 days. I hope we have done our part, if not 100%, we could able to say that at least 75% of your expectations are fulfilled through this ATAL Academy sponsored faculty development program. With that, I stop my presentation. If you have any queries relevant to my presentation or out of my presentation, you are always encouraged to ask questions. Thank you once again for all the faculty members who are supported directly and indirectly for the successful conduct of this 6 days online FDP.
Thank you, sir. Thank you, sir.
Participants, any queries or any questions regarding?
No queries, ma'am.
Ma'am, next speaker is ready.
Wait, I confirm with her, sir. Also, 1 minute, sir.
Question போட்டலாமா இப்போ போட்டலாமா போட்ட டைம் இருக்காதா ஓகே. ஓ! அவங்களே ஓப்பன் பண்ணுவாங்களா? அத அவங்க தான் பண்ணுவாங்களா? அத சொல்லணும்ல அவங்கள்ட்ட. எத்தன மணிக்கு? அது சொல்லிருவோம். இருங்க. Yes. Dear participants, already we have posted MCQ question in ATAL portal. I think as per the schedule after this presentation, we have one more presentation, 3:30 to 6:30. Then by 6:30, you'll be getting MCQ questions, and you are all requested both MCQ question and followed by feedback link. So you are all requested to answer MCQ question and submit your valuable feedback. Then we'll be having validatory function by 7:30. We have invited Dr. Nagarajan, Director Value Energy, for giving keynote speech during that session. I request all of you to stay back till we complete validatory function. Thank you so much. So we can take 5 to 10 minutes break. You can have a cup of tea and come back for next session.
Kanambaran sir, can you hear me, sir?
Yes, madam. Audible.
Audible, sir. Can we start, sir?
Yes, madam.
Okay, sir.
Ah.
So participants already well known about A. Kanambaran sir. Yesterday he presented the topic in AA algorithm from Shastra University, Tanjavur. So now also he presented his session as simulation part of electric vehicles. So you can start, sir. Session hand over to you. Thank you, sir.
Yes, madam.
Welcome. Thank you,
Thank
sir.
you, madam. Thank you, madam. Whether my presentation visible, ma'am?
Yes, sir. No, sir. The presentation is not visible. Audible one.
I will open it, ma'am. Is it visible now?
Yes, sir. Visible. Thank
First, I will change the slide, ma'am. You check it and give me the feedback. Now, whether my slides are changed or what, madam?
No.
No.
Hi.
I changed my second slide. Is it visible or what? From title slide.
Sir, கொஞ்சம் இது print full screen view. Can you make a full screen view, sir?
Otherwise, I will do one thing, madam. I will share my entire screen.
Because the slide sizes are smaller. That is why.
Once again, madam, I will share my entire screen, madam.
Okay, sir. No problem, sir.
I changed my first slide, ma'am. Second slide is there.
Visible, sir. Perfect.
Right.
Thank
Okay.
you. Thank you so much, sir.
I'll start, ma'am. All right, ma'am. Thank you, ma'am. So good afternoon, everyone. I'm delighted to be here today to share some insights on AI algorithm development, simulation, and testing for integrating renewable energy sources into electric vehicle charging networks. So this is the presentation outline. So we begin with the first and most important step, defining the problem and goal. So here we clearly state the objective. For example, minimizing the charging cost, reducing grid stress, or maximizing the renewable utilization. So along with the objective, we also define metrics for evaluation such as accuracy, error, cost savings, or the stability indices. So without a well-defined goal, the entire AI pipeline risks become directionless. Once the problem is defined, the next step is to choose an appropriate simulation tool. So depending on the complexity of the system, we may use different platforms such as MATLAB Simulink for power system level modeling, or Python with TensorFlow, PyTorch, or any optimization libraries for AI development can be used. In many cases, hybrid approach is used, combining systems modeling with the AI models. The third stage is preparing the input data. So AI algorithm depends heavily on data. So yesterday we discussed about how the data flow takes place from the beginning EV station to the cloud. So this may come for real measurements. For example, charging station logs, renewable generation profiles, or market prices, or from the synthetic data generated through simulations. So the pre-processing is crucial, including cleaning, normalization, and feature extraction to ensure the AI learns meaningful patterns. And the next step is to the core of the process, implementing the AI algorithm. So this could involve supervised or unsupervised learning, the reinforcement learning for control, or optimization-based AI techniques. So depending on the application, algorithm may range from regression models to advanced deep reinforcement learning controllers. Once the algorithm is implemented, so just you are going to run the simulations to compare the AI-based approaches against a baseline when compared with without AI. So typically rule-based or heuristic methods. So this helps us understand the incremental benefits of using AI. So after the successful simulations, we move to the performance evaluation. Here we quantify how well the AI performed using indicators. So we discussed about various KPI such as prediction accuracy, error rates, computational cost, and the system stability improvements. And after all these things, following this, the stress testing is conducted. So apart from the data available, we have the AI model may perform well under normal conditions, but it failed to under noise or missing data or extreme demand and renewable fluctuations. So we performed this stress testing. So that this stress testing ensures the robustness, reliability in real world conditions. So finally, if the work demands real-time implementations, just we go for hardware in loop, I think HIL. So in this hardware loop testing, it actually the simulation with the reality will be tested. So this step bridges simulation with the reality by testing the AI algorithm in real-time hardware environment. Such as various microcontrollers are here. So EV chargers, then renewable power hardware. So this gives confidence before implementing AI into actual grid integrated charging systems. So first now we are going to see the problem definition and goal. So when we begin with the problem definition, the key question is what exactly should AI algorithm do in this application? For example, in image processing, the AI may need to classify the objects. In our case, with the renewable energy and EV charging networks, the AI could have several possible roles. So the first one is predictive tasks, such as forecasting load demand, renewable generation, or electricity prices. Then optimization tasks, such as minimizing charging cost, maximizing renewable utilization, or optimally dispatching power between battery storage, grid, and EVs. And we need to perform the control action also. So the control tasks such as regulating charging rates, managing the SOC, that is state of charge of batteries, or ensuring voltage and frequency stability of the grid. Once the task is defined, the second step is to establish the performance metrics. So we discussed in the KPI. These metrics serve as a benchmark to evaluate the AI's success rate. Some common metrics include accuracy or prediction error for forecasting tasks, cost reduction for economic optimization, convergence speed and scalability for optimization algorithms, and stability robustness for real-time control in dynamic grid conditions. So the selection of the objective and metrics is absolutely critical because it guides the algorithm design, the data requirements, and the evaluation strategy. In other words, this step defines target we are aiming for and all subsequent steps in the workflow towards achieving it. So the selection of simulation environment after defining the problem and setting the objectives, the next step is to select an appropriate simulation and development environment. The choice of tool depends largely on the type of AI task and the system being studied. For general AI and machine learning development, Python has become a dominant platform. Libraries such as NumPy and Pandas handle numerical computations and data preprocessing, while TensorFlow and PyTorch are widely used for deep learning. Scikit-learn is another reliable library for classical machine learning algorithms. And then for control and optimization problems, MATLAB Simulink remains very popular, especially in power and energy domains, because of its strong system modeling and control toolbox. So MATLAB is preferred. So however, Python alternatives such as CVXPY and SciPy.optimize provide powerful optimization capabilities, and GIM environment are often used for reinforced learning and control policy training. And then when we move towards the implementation, the embedded hardware implementation of AI tools like MATLAB and simulation can generate embedded C. Why? Because the objective is to implement in real time. So apart from prediction and optimization, it should be implemented in real time. So we depend real-time microcontrollers. So that can be programmed using embedded C with the help of the MATLAB and Simulink environment. So these MATLAB and Simulink can generate embedded C code directly for microcontrollers or DSPs. For circuit and hardware level testing, the platforms such as Proteus or Model Sim may be used. In some cases, researchers also built custom test beds where AI models are integrated into real charging hardware or renewable energy converters. So this is based on the interest. Okay, we can build our own also. So thus the simulation tool is not one size fits all solutions. It is chosen based on the balance between algorithm complexity, modeling needs, and the deployment target. Then the preparation of input data. Once the tools are chosen, the next crucial step is preparing the input data. So AI algorithms are only as good as the data they are trained and tested on. So the first option is to work with real world data sets. For our application, it might include the EV charging station logs, renewable energy generation profiles, weather data, then the electricity market prices, and the grid measurement signals. So these are all the things will be taken into account. However, in many research cases, real datasets may not be available due to privacy restrictions or cost or lack of infrastructure. So in such cases, we rely on synthetic disk data. So we can generate a similar set of data using the simulation tools. So this generated random data through the simulation environments are using physical-based mathematical models of renewable sources and EV charging behavior. So this synthetic data provides flexibility to study edge cases that might be rare in real data sets, but are important for robustness. Then pre-process. So after collection, all data must be the test pre-processing. So this typically involves steps such as normalization. So why? Because the different parameters are available with the different magnitudes rating. So it must be normalized. So to bring variable to comparable scale, and to denoising to eliminate measurement errors, and to handling missing values, and most importantly the feature extraction to capture the essential patterns so that the AI algorithm should learn. And without proper data preparation, even the most sophisticated AI algorithm will fail to deliver reliable results. So this is the very essential step, the very first step of using AI, so preparation of the input data. So, in many experts agree that the data processing accounts for nearly 70% of the total effort in any AI project. So, the remaining 30% only what the AI is going to do to get the correct or desired results. And implementation of the algorithm. So, the data prepared, we now implement the AI algorithm appropriate to the task. The selection must be aligned with the control objective, the data characteristics, and the real-time constraints. First, the prediction, that is the forecasting. So, different models are used in simulation. So, classical regression, gradient boosting, and deep models are used here. And then for RES EVCN, that is our renewable energy integration and electric vehicle charging networks. Actually, we use day head PV wind generation, and then EV arrival rates, and then station dwell time, and price forecast. So, as a result, actually, we can train and validate with the rolling origin evaluation to avoid leakage, and we can regularize to prevent the overfitting. The second one is the optimization, the decision-making parts. So, different formulations are there, like model-based, then model-free, learning-based, and distributed consensus control. These are all the different formulations available for the sake of optimization, especially in the decision-making. And then classification for discrete decisions. So the decision trees or random forest, SPMs, CNNs are used as a model. And then faulty detection, user intent recognition, event classification. We use RES EVCN. And then for emphasis, the classification prefer interruptible model for operational alarms. So to calibrate probabilities for thresholding. So this is how the algorithm will be implemented. next to run the simulations. So once the algorithm is developed, the next logical step is to run the simulations. So the purpose here to validate whether the AI approach is working as intended and to compare it again with the conventional strategies. So the first step is to feed the prepared input data into the AI algorithm. This includes historical data sets for training and unseen data sets for testing. So for example, if you have 100 set of data, about more than 50, 60, 70 data will be given to train the model, and remaining will be treated as unknown, unseen data. And for those unseen data, the model will be tested. So we can do compare and we can find out the accuracy using the error rate. So the simulation environment acts as a sandbox that mimics real-world operating conditions of renewable sources, EV charging behavior, and the grid interactions. So when we then conduct multiple test cases to establish a benchmark, we always begin with a baseline scenario, so where the system operates without AI. For the sake of understanding, for the sake of comparing the performance of AI, we go for a baseline scenario where the system operates without AI. So typically under rule-based in the sense what, like if then. If SOC lies less than 20%, we must charge the battery. If it exceeds 90%, the charging must be stopped. If PV available, if no charge there, then if a rule-based system suggests to charge the EV, so it will not forecast whether PV available or not. But AI, unlike this rule-based AI, will forecast and will give a suggestion to improve the overall performance. So typically under rule-based or heuristic methods, for instance, charging might be scheduled based on fixed time of use tariffs or simple peak saving rules. So next we run the AI enhanced scenario where our developed algorithm is applied to the same operating conditions. By comparing the outputs of baseline and AI cases, we can quantify the improvements delivered by the AI. So during this process, the parameter tuning becomes important. So why? Because whenever we address the nonlinear issues and multivariable system, this adjustment parameter plays a vital role towards the convergence. So for machine learning model, this involves adjusting hyperparameters such as the learning rate, batch size, or the number of training iterations. For optimization algorithms, this could mean defining iteration limits, tolerance levels, or the convergence criteria. So the goal is to achieve the best trade-off between the performance, stability, and the computational cost. In short, simulation allows us stress test that the algorithm in a controlled environment, identify weakness, and fine-tune its performance before moving to more rigorous evaluation and real-time testing. So a general test can be done with the help of running the simulations. Then the performance evaluation. So after running simulations, the next step to evaluate the performance of the AI algorithm in a systematic and quantitative manner. So this is where we apply well-defined metrics that align with the nature of the task. For classification problems such as fault detection or event recognition, we rely on metrics like accuracy, precision, and recall. So accuracy gives the overall correctness. Precision shows the how many predicted positives were truly positive, and recall measures how many actual positives were successfully identified. So based on the problem type, we must select. For prediction and forecasting tasks such as renewable energy or EV demand or common error-based metrics included, so mean absolute error (MAE) and root mean square error (RMSE). So these two are the performance measure. So if the value is about 0, that represents the AI performs well, perfect. And in some cases, percentage-based measures like MAP, this allows us to measure how close the AI predictions are to the actual observed values. Then for optimization tasks, the emphasis is on the system level improvements. So metrics may include cost reduction compared to the baseline scheduling, reduction in power loss, and the speed of convergence of the optimization algorithm. Finally, the control-oriented task. We look at a classical control system metrics such as response time, overshoot, and steady-state error. So this helps us evaluate the stability of the robustness of the AI-based controllers in managing grid-connected charging systems. So the important point is the one size does not fit all. So each application requires a tailored set of metrics. So by using these evaluation measures, we can objectively demonstrate the added value of the AI compared to traditional rule-based methods. Then the next one is the stress testing. So once the AI algorithm performs well under normal operating conditions, especially in the simulation, without any the noise signal input, the next step is to ensure its robustness through the stress testing. So in real world energy systems, so conditions are rarely perfect. So and the AI solution must remain reliable even under uncertainty. So in case of any malfunction in the sensor side or any error in the computational part in the pre-processing, everything must be taken care by this algorithm. So we go for stress testing. So one important aspect is testing the algorithm under noisy data. So sensor readings from the EV chargers, renewable sources, or the grid often contain measurement noise. So the AI should still be able to make stable decisions without overacting to small disturbances. So we also tested the model with the missing or incomplete inputs. For example, whether forecast may be unavailable or some smart meters may temporarily lose communication. A robust AI design should be able to handle such gaps, either through imputation, redundancy, or fallback strategies. So these are all the alternate, especially during missing or incomplete inputs. The another important dimension is extreme operating conditions. So this include scenarios such as very high EV penetration, unusually low renewable generation, sudden spikes in demand, or fault in charging infrastructures. So whenever the condition exceeds the boundary what we defined already, it will be treated as extreme operating conditions. So evaluating the AI under such boundary conditions reveals whether it can generalize beyond the training environment. And then a powerful technique used in this stage is nothing but Monte Carlo simulation, where we run thousands of randomized scenarios with a varying demand, generation, and noisy levels. So this statistical approach helps us quantify the probability of failure and ensures confidence in real-world implementation. So finally, it is good practice to compare AI results with the theoretical or conventional methods. For example, comparing reinforced learning with a well-known optimization algorithm like MILP, or comparing neural network forecaster with a traditional regression model. So this benchmarking validates the AI is not only working, but is indeed offering measurable improvements over established approaches. Then visualizations. So in addition to numerical metrics, visualization are very effective way to demonstrate how the behavior and the effectiveness of the AI algorithms. So graphs allows us to communicate results intuitively and provide insights that raw numbers often cannot capture. So why? Because we cannot see the value, change in values or whatever it is continuously. So the help of the graphical representation, we can see everything. Then for optimization talks, we commonly plot convergent curves where the x-axis represents iterations. Actually, during results, you can see that. Just I will explain the convergent curves. So convergence that represents how the response goes towards the desired output. So mostly the convergent curves converge towards the zero error. So where the x-axis represents the iterations, number of iterations involved. Typically 20 to 30 iterations enough when we go for any optimization technique. So y-axis shows the cost or accuracy. I told you already, the convergency curves represents the minimization. In case of error, it will be 0. In case of cost, minimum cost. In case of losses, minimum losses. So like that. A well-performing AI algorithm should show rapid convergence to a stable optimum, ideally faster, better than conventional approaches. Then for classification problems, we use the confusion matrix, which summarizes the true positives, false positives, and true negatives and false negatives. So So this provides a detailed view where the classifier performs well and where it struggles, especially in imbalanced data sets such as rare fault detection. In the context of energy systems, one effective visualization is plotting power loss versus demand. So this helps us evaluate how AI-based scheduling reduces system losses under different demand scenarios compared to the baseline strategies. Finally, for control appliances. So the next step is to control. We examine control response curve, such as step response plots. So these illustrate response time, overshoot, steady state error. So it gives a clear indication of the system stability and the robustness and or AI-based control. So these are all the different way of representing the KPIs. So together, these graphical results provide strong evidence of the AI's benefits. They make performance comparison more transparent, highlight key improvements, and build confidence in the algorithms deployments. So it is optional actually. So based on the application demand, we can go for a hardware in loop, simply known as HIL. So the final step in the workflow. So if the deployment is planned for real time, so the hardware in loop testing, often abbreviated as HIL, is recommended. So in this stage, the AI algorithm that we developed and validated in simulation is connected to physical hardware components, or at least to a real-time hardware emulator. So actually, HSIL is nothing but what? A real-time hardware emulator. So the purpose is to test how the algorithm behaves under realistic conditions with the actual sensor inputs and the system latencies. So the real-time constraints actually not taken into account, even including the stress testing. So we go for HIL. So several platforms are commonly used in HIL. Just I will list a few important HIL used in laboratories. The DSpace or OPAL-AT. So the DSpace and OPAL-AT, which are high performance real-time simulators, and it is widely used in power and energy research. Then microcontroller-based platforms such as Arduino or ESP32, which allow embedding AI models exported from MATLAB or Python. So these platforms are cost-effective for testing algorithms in EV chargers or battery management systems. Then MATLAB Simulating Real Time, which directly links system models with the hardware boards, enabling ray-bit prototyping. So dedicated boards are available. The combination of MATLAB, we can emulate it. So in a typical setup, real sensor signals, for example, current, voltage, temperature, or the state of charge, are fed into the AI controller. Then the AI then processes these inputs in real time and sends control actions back to the simulated or physical plant. So this closed loop setup allows us to evaluate stability, robustness, and the computational feasibility under hardware constraints. The HIL testing provides the final assurance that the algorithm is not only accurate in simulation but also deployable in practice. So, it acts as a bridge between the simulation and the real-time implementation. So, actually, about 99% of constraints are tested with the simulation tool, the remaining 1% actually towards the real-time implementation can be checked using this HIL, hardware in loop. Next, the iteration and the refinement. So even after an algorithm has been trained, tested, and evaluated, the development process does not end there. Why? Because the model itself can be updated, right, in future. So AI models requires continuous refinement to achieve optimal performance and practical deployability. So the first step in refinement is hyperparameter tuning. So parameters such as the learning rate, batch size, number of layers. As I said already, the AI model itself can be altered, updated. And regularization coefficients can drastically affect the accuracy and stability of the model. So systematic methods like grid search, random search, or more advanced optimization can be used to identify the best configuration. And then the second approach is to try to alternative AI models. So different AI models are there. So we can try with multiple AI models to get the desired good results. For example, if LSTM does not capture the long-term pattern effectively, we may switch to transformer-based models. So if the reinforced learning algorithm converges slowly, we might test policy gradient methods or hybrid optimization approaches. So like based on the real-time application requirement, we can select the suitable AI models. So comparing alternatives ensures that we are not locked into a single method, but are instead choosing the most suitable tool for the problem. Finally, we must optimize for speed, memory, and robustness. So whenever we try to implement AI, we must consider these three parameters: the speed, the memory occupied, and the robustness, the strength of the model. So in a research setting, high complexity models may be acceptable, but in real implementation, especially on embedded platforms like EV chargers or controllers, we must minimize inference time and memory usage. Techniques such as model compression, tuning, quantization, and edge deployment optimizations are crucial to make the AI both efficient and reliable. Thank you. So this is what about the small introduction to the simulation. So what we are going to see today. So we continue the AI development and simulation. Shall I proceed?
Sir?
Shall I proceed the simulation, madam?
No problem, sir. No problem. Start, sir.
Okay, whether my screen is visible?
Yes, sir. Visible now.
Okay, so before going to see the complex mathematical calculations, as a beginner in the beginning level, you can approach ChatGPT that helps you to write the code. Okay, so different platforms are there. If you have a MATLAB, you can use MATLAB code to run it, or you can go for a Python. It's a open source, or you can use the HTML also. So I'm going to give about 5-6 programs explained today. Few programs using MATLAB and few from HTML coding,
Sir?
right? Can you able to see my screen, madam?
Yes, sir. You enable, sir. Screen not visible now. You enable.
Once again, madam. Is it visible now?
Yes, sir. Yes, sir.
Okay, first program, just you are going to see the load forecasting using neural network. Okay. So can you able to see my screen, madam?
Yes, sir. Yes, sir. Yes, sir. Visible.
Okay. So in this, yes, first I will explain about the program and then I will run it. So in this example, actually we are demonstrating how a neural network in MATLAB can be used to periodic load demand across 24 hours a day. The process involves 5 main steps: the data preparation. Here the step 1 is, so whatever we discussed in the presentation, PPT presentation, you can see. So first one involves the data preparation. So in this data preparation, neural networks work with better inputs within a small range, both inputs and outputs. Both are normalized between 0 and 1. This helps the algorithm learn patterns faster and avoid numerical instability. And second one is train a neural network. So the samples, 24-hour samples taken into account, correct? 1 to 24, right? So the model will be trained for 24-hour inputs. Then the next step is predictions. After training, the network is ready to make predictions. So the output form of the network is still in the normalized range. So we rescale it back to the kilowatts to match the real data. So as I said already, the normalization process will be done to run the AI. Why? Because based on the typical application and the parameters what we selected, the value and range will differ. So that can be normalized. So this rescale again will convert back into the original. Then to check how well the network performed, we calculate 2 errors: the mean squared error, the another one is mean absolute error. I had told you already, if both values are nearly 0, that represents the model works best. A smaller value means the predictions are closer to the actual one. So finally, we plot both actual and predicted load profiles in the graph. So I'll run the code. So we can visualize the results. So like hours of the day, load demand, then actual load, predicted load, everything displayed here, right? So the entire algorithm run based on the neural network. So can you able to see my screen, madam? Is it properly visible?
Yes, sir, properly. Perfect, sir.
Okay, right. So where you can see the actual load and predicted load, as I said already, among 100 samples, few portion of the samples will be used to train the network, and few will be the unseen data used to check its actual response. So the blue color that represents the actual load, and the red color represents the predicted load. You can see both are lies almost in same line, except very few places. In the beginning, actually difference more, and of course in the last also the difference will be little more. But in between, you can see the actual and predicted load lies on the same axis. So this is how the neural network used here to perform the load forecasting. So let's move to the next program.
Yes, sir.
So here you can see how the neural network works, what are all the training progress takes place, especially the terms and definition that belongs to the training progress will be displayed here. So how many number of neurons included, what type of algorithm used here to run the neural network, everything will be displayed, and the corresponding performance parameters are also tabulated, and you can see the network diagram also. So as I said already, based on the interest and based on your application requirement, so you can work towards the particular AI model. Okay, so this is what load forecasting user using neural network. So next, I'm going to explain about the economic dispatch using PSO. So PSO is nothing but particle swarm optimization. So all the equations, the PDE, that is quadratic equations. So whenever the order becomes high, very difficult to solve. And when we try to solve with the help of the normal mathematical relations, it will take more time. So we go for optimization methods, PSO. I'll run the model, economic dispatch using the PSO. So here you can see in the x-axis, you can see the number of iterations, and y-axis you can see the cost. So initially it starts above 3,720, and each iterations the results converge towards the local minima. So actually in real-time scenario, the relationship will not be like linear, it will be more complex, so very difficult to find out. So we must evaluate each and every point, but in case of PSO, it will try to converge towards the actual results. So in the x-axis, you can see nearly 30th iteration, it is settled down. So it reaches the minimum cost. So 30 iterations enough. Actually, this is a typical example. Actually, for this problem, 30 iterations results good result. But based on your application target, this number of iterations will vary. But however, 20 to 30 iterations enough to reach the minimum cost, the local minima using PSO. So this is the typical example program to find out the economic dispatch to get the minimum cost. I will explain about the program. I forgot to explain. Actually, this MATLAB code demonstrates how the PSO can be applied to solve the ED problem, the economic dispatch problem. So which aims to allocate power generation among multiple generators to meet demand at a minimum cost. So the real-time problem and the solution will be applicable same for all the real-time scenarios. Whatever the concept we used here for ED that can be applied in EV charging also. So here, first we need to define the system data. Each generator, actually the cost function will be represented in terms of the quadratic equation. So the second order quadratic equation. So we can, where we can limit the maximum and the minimum generation limits, the boundary will be set. So this is what the very first step. So minimum and maximum limits are set. You can see in the screen. Then PSO parameters are used here to run the model to get the local minima value. So this is how the PSO design. So it starts to run in the sense what iterations. So it will be realized through for loops. So it starts from 0 iteration, that is number 1 iteration. So and it will the actual results converge towards the minimum cost. So randomly initialized values will be initialized, then it will move towards the actual desired minimum cost. So P best, C best, and move towards the global best. So after finding the global best, the results will be displayed. So this is what we just saw previously, the economic dispatch using the PSO. Okay, next program, just you are going to see that it demonstrates how to simulate and test the AA algorithm, especially using a neural network. So the aim is to approximately an IC sine function. So we are just going to generate 200 samples between the period of -2 pi by 2 plus 2 pi. Just you think about a sinusoidal function, right? So the target values are generated as a sine function plus very small random noise. So the data set is split into training and testing. So 70% will be the training and the 30% for testing to evaluate the generalization. So first program itself, we discussed about neural network, how it works. So here a feed forward neural network is created using the function, the toolbox available in the MATLAB FitNet with the 10 hidden neurons, and the training uses the Levenberg-Marquardt algorithm with the goal of 1 e power -5 and 200 epochs. So data division is done manually to ensure the training use only the training subset and testing uses the remaining data. And then to test the data, so after training, the predictions are obtained for both training and testing data. So again, we use the performance parameters MSC to know the accuracy of the proposed system. And finally, we can visualize the results. So I will run it, the AA algorithm using the neural network, right? So 200 iterations will be there, training results, and finally it will display the result. Can you able to see the result? So -2 pi by 2 plus 2 pi. So to complete cycles, you can see sinusoidal waveform. So the original data represented by the blue color dots. So that shows the sinusoidal function. And about red color is the training predictions, and actually green color that represents the predicted data. So this is how the predicted data works on the particular series. So once again, I will run it. So you can see actually, I want to say something here about this results what we obtained here. So we are giving a very simple solution, a simple problem. Sometimes simple problem is not suitable for AI. So why? Because you can see the huge error between the actual set and the tested predictions. So for simple problem, AA is mostly not recommended. If it is more complex, then it is recommended. Okay, so this is how the AA returns results. This is just only for the sake of understanding how the neural network used here in AA to find out the to perform the predictions. Okay, next I will move to the next program. So here the case study what we discussed in the yesterday. Actually, in this program, AI technique is used here. This is what actually EV, then PV and battery energy all are taken into account. So in this case, how we are just going to compare how the rule-based system responds and how the AI works. So this MATLAB code demonstrates how to schedule an EV fleet, PV, and the battery energy storage systems using both rule-based heuristics and AI-based optimization, especially linear programming to minimize energy cost while respecting the physical and operational constraints. So as I said already, we must consider the grid parameters also. The first one is about the system setup. Actually, total time horizon 24 hours taken into account from 1 to 24. The one whole day is taken into account from our 0 to 23 or 1 to 24. Then EV fleet 30 EVs are taken into account, each with a 7 kilowatt maximum charging. So we need to charge 30 EVs. And the battery energy storage systems, the BES rating actually about 300 kilowatt peak and following by sinusoidal daily profile. The base load actually 0 to focus on EV scheduling. Then tariff, it is based on the time of use with the peak, mid peak and off peak rates. So there are 3 different tariffs are actually defined here. So now come to the optimization. So rule-based scheduling. First, actually, rule-based scheduling used here. So it works like EV charge only during off EV greater than 200 kilowatt. So EV it starts to charging whenever the PV is more than 200 kilowatt. The second constraint about BES, it charges from spare PV during off peak and discharge during peak hours. So this is how rule-based system functionality defined here. Then constraints. So EV energy requirement, then aggregator power limits, BESS, SOC. These are all the constraints are taken into account in the BES. And the following metrics are calculated. Unserved EV energy. Why? Because we cannot utilize all EV effectively. So unserved EV energy is calculated. Then total EV energy served calculated. Then grid cost, peak grid demand, all those things are measured. So in the rule-based scheduling, simple heuristic-based approach used here. And next, AI scheduling. As I said already, linear programming used here with the BES. So here the decision variables, EV charging power per hour, grid import, BES charge discharge, SOC, then PV curtailment and slack for unmet EV energy. So these are all the constraints taken into account for in AI. And objective. So what the objective used in this AI-based scheduling, minimizing the total grid cost plus penalties. So for PV curtailment and unmet EV energy. So this is the objective we set here. Then the constraints. So the following constraints are taken into account in AI-based scheduling. The power balance per hour EV plus BESS plus grid. It should be equal to PV minus base load. So this is the relation considered here. Then SOC dynamics. So to perform the operation against the battery energy storage system, the change in SOC is taken into account. So SOC dynamics. Then EV energy requirement. So by departure with the slack allowance, we consider the EV energy requirement also. And finally, the on-site EV aggregate limits. So these are all the parameters, constraints taken into account to run the AI. And actually, solver used from the MATLAB is nothing but linear programming with a dual simplex algorithm. So these toolbox helps to simplify these mathematical equations. Otherwise, the length of the code will be large. So the toolbox that helps you to reduce the coding, the line, right? So next, the results. The following results are actually numerical values are displayed here in the summary table, especially the cost for both rule-based and EAA, then peak grid power served demand, then served energy, unserved energy, all are listed here. And we can visualize using the graphs also. So I will run the simulation. So it returns whatever the values we listed, everything written here. First, I will show you the numerical values, whatever the values tabulated from the MATLAB command window. Actually, the rule-based results, the total cost of about 2,495.6, and peak grid from the grid actually 250 kilowatt, and EV energy served 648, and unserved energy 120. So if you do compare with the AI LP, actually total cost increased. Actually, the AI LP comparison value. So this 2,495.6 rupees can be eliminated by using the AI, and then peak grid. So this 250 kilowatt power consumption that can be reduced when compared with the rule based. And the EV energy served comparatively more, about 1036 kilowatt hour delivered, whereas rule based delivers only 648. So unserved EV will be less when compared with rule based, about 94 here, whereas rule based it will be 120. So the PV curtailment is about 348.6 kilowatt hour. So it utilizes the grid more effectively. Then EV energy served, it is already listed, and it is shown again about 84.4 percentage from rule, and more than 134.9 percentage from the AI. So now I'll move to the visualization, graphical results. So whatever we just saw in the table, it is represented as a graph here from 0 to 24 hours, the energy cost. So AI based, it keeps always minimum nearly zero and compared with the rule based. The rule based cost gets increased, so based on the time, especially during peak hours, the cost will be more. And the next one shows the PV curtailment. The PV curtailment, that AA only, it is applicable to AA only. Why? Because by applying AA technique, we just achieve the PV curtailment. So PV curtailment is nothing but the PV power, whenever the PV power is forecasted and make it assured available, then to meet out the grid stability, the amount of power generated from the grid will be reduced. So this is applicable to only AI. So by applying AI, we can achieve the PV curtailment. Then the next third figure 2, EV charging and aggregate here. So that shows the two relations where you can see the EV charging, blue color represents AA. It is always more when compared with the rule based. And now the next figure about grid import and BESS. So there are three waveforms shown here, graph. The first one is PV profile. So with the help of AA, we can forecast the PV profile. So you can see the grid import will be almost zero when PV is available. So as a result, BAS actually rule-based works always, whereas AI perfectly utilizes the PV and effectively operate the BAS. So this is how we can understand how the AI works by comparing the result with the rule-based. So these are all the 4 typical programs. Actually, I just with the help of the ChatGPT I prepared. So you can use the, you can get the help. So and if you are familiar with objective functions, you can go and edit it. And if you have an idea about introducing additional constraints, you can include it. So either you can update the model or you can improve the performance. So next, I'm going to explain 3 more programs using the HTML code. So if you don't mind, shall we take a 15 minutes break to continue the, madam, to continue the session using HTML code?
Do you want any break, sir?
If you don't mind, if you give me a 15 minutes break, then we can restart the programming using HTML code.
Okay, sir. No problem, sir.
4:45, I will come and join, madam.
Okay, sir. Okay, sir. Okay,
Thank
sir.
you. Thank you, madam.
Are requested to join after 15 minutes team break. Continue the session at 4:45 p.m. Thank
Okay,
you, sir.
thank you. Thank you, madam.
15 minutes of break. 15 minutes of break.
Hello, ma'am.
Sir?
I'm ready here, ma'am.
Okay, sir. Participants? Can we start the session?
Yes, ma'am.
Right.
Okay, sir, you can start, sir.
Okay, madam. Thank you. So next, what we are going to see. So far, we discussed about how to use tools like MATLAB to run the AI programs. Next, what we are going to see. If no MATLAB is there and no not familiar with Python, there is another way of running AI algorithm is there. So it is nothing but running the HTML coding. So this is what we are going to see in this session. First, I'll start. Actually, I prepared 3 different programs to explain, especially in the EDPV and interface. But for the sake of interest and for your experience, I'm going to share how to use the ChatGPT to write the code and how to make use of it. Right. So I will share my screen. Is it visible, madam?
Yes, sir. Visible, sir. Visible.
So you can see the ChatGPT window now. First, I'm going to explain. I asked ChatGPT to write one code for forecasting. So forecasting only where we need AI. Then we can prepare other programs also. First, I'm going to ask ChatGPT to write one forecasting program. So when we ask ChatGPT to write a code, it starts to write the code. So actually, it will suggest either Python code or MATLAB. So just you are asking ChatGPT to simply write a program, so it will think which area. So if I have a previous discussion with ChatGPT relevant to this topic, it will try to give a similar forecasting program, so that it takes time. Mostly it will return either Python code or MATLAB code. So if you have a MATLAB, you can make use of it. And if you are familiar with Python as an open source, you can use Python code also. If both are not possible, you can follow this method using preparing a web page using HTML code. Yes. So as I said already, it created one Python code. Okay, please note down the first step. We need to open the notepad and you can paste it. Okay, program is not yet generated. So I will try again. Okay, it starts to write the code. Okay, so this is like actually it is like for Python. Okay, so if you are familiar, you can directly make use of this code. Why? Because as I said already, Python is an open source platform where more toolboxes are available, so we can make use of it. So for beginners, what I suggest, you can make use of the HTML page. So what I'm going to ask the same ChatGPT to write the code using HTML. So a time series forecasting generated. So this is only for the sake of idea how the forecasting program works. So you can forecast any parameter like weather condition or price of a product, like that. So the main advantage of using this HTML code, you don't need any additional component like MATLAB or Python to run it. So if whenever we try to prompt ChatGPT properly, we can get the desired coding. So we did not ask anything about the ChatGPT, especially the application area. We just simply asked to write one forecasting program. So we don't know about which parameter it forecast. So when we running the at the time of running only we can know the parameter. So as I said already, in case of MATLAB code or Python code, it will be very less number of lines. Why? Because everything will be available in the toolbox. But here, as a HTML code, it need to write everything as a separate command lines. The program is not yet over. Try to write both sides. Okay, see here HTML over. Okay, so this program, any one program we can copy. First, I'm going to copy the response one. So we must tell to ChatGPT which one we are going to use. I'm just going to run both programs. So this is how we can run the HTML, right? So open the notepad, paste the code. So actually the program lines are nearly 350. So you can save this file. So at the time of saving the file, so we must use for HTML extension. So this is forecasting.html like this. Once the program saved in a particular location, it will be converted into the corresponding web page. Can you able to see the forecasting? That page is actually saved here as a web page. So you can double click and you can open it. So this is the main advantage of web page. So unlike no other MATLAB or Python, no need of any additional component. We can run it with the help of the web page itself. So it asks to load the forecast CSV as well as any image also we can give. So usually whenever ChatGPT write the code, it will write the code along with the default data. So here you can see the option load demo data, that is load synthetic series. So actually it will find out the data by means of any other simulation or some other methods using mathematical formulae. Random data will be generated and that data will be sent to the code. So I just loaded the synthetic data series for a month of January to February. So this is how the actual data history available, and now we can forecast it. Okay, so that what will happen? I don't know whether it takes more time or not. So the concept behind it, actually, the ChatGPT helps you to write, to develop the code, but we must carefully check it at our end. Okay. So actually, it creates a perfect graphical user interface, and it also add option to include your data either by means of Excel database CSV file or PNG, and you can load it and you can run it to get the to see the forecasting. Okay, I'll check the another code. Just to go to the ChatGPT window, and I'm going to copy the second code response to, and I'm going to use the same page. So you can create multiple pages. Just I'm going to run the same program for the sake of demo. I'm using the same. If you update the page, the next program will be showing. Okay, so actually this program needs actually the input data. About 120 epochs given. So about 120 times it will run. We need to wait to see the result. We already discussed about the MEAE and RMSE. So we can see that actual and predicted will be almost nearly same. So okay, so this is how we can use the HTML web page to check our AI program. Okay, so next time I'm going to ask the AI to write the load forecasting, right? We already run the load forecasting using neural network in MATLAB. Now we are going to see using the HTML code. So again, it starts to write the Python code only. Why? Because many users, researchers, they are using only Python. So in real time also during implementation, we can use the same Python code in Raspberry. So it is easy to implement also, but I'm just going to ask to rewrite the program using HTML. So actually, the major advantage of ChatGPT in each place, it will mention what kind of steps involved. So you can easily go and see what are all the data taken, what are all the constraints taken, what type of algorithm used, and we can ask ChatGPT to develop the program customized control algorithm also. So now the program is ready. In the same sheet, I'm going to load it. And I'm going to see the response. So instead of loading, I'm just going to load the demo data, and I'm going to train the AI to see the forecasting rate. 24-hour data is given, 12 a.m. to 4 p.m. Training is not yet over. About 180 books given. So as a HTML code, it will take time to run it. Okay, so similarly, whatever the application requirement, you can develop your own code. No need of MATLAB and any other like Python. So I'll ask another one code from ChatGPT. So the code is ready. You can run it now. So it keeps the display format as it is. So especially for such AI programs, definitely this approach will take more time. Why? Because everything handled and everything solved by HTML as a front end. So for lightweight programs, we can go for HTML, but for other high complex problems, we must go either with MATLAB or Python. Okay. Okay, so it took more time. So okay, this is the way without MATLAB and Python, we can write the program, use the help of the ChatGPT, and we can run it. So next, I'm going to explain. Yes, now only it written the answer. I closed here. Okay, so this is how so the participants can make use of this ChatGPT and HTML page to run very small AI programs. Okay, next I'm going to explain the typical program belongs to our topic. So in this HTML code, actually we considered EV charging along with the PV and battery energy storage, both tool-based and AI techniques compared. So either custom data may be used here to run to receive the response. There is an option available to select the sample file. First, I will explain the test relations, the various graphs what we obtained by loading the sample data, and then again I will go and explain the another Excel file where we have our own data. So the entire simulation done for 24 hours. The first one shows the grid input power. So when we prefer AI, the amount of grid power imported is less, about 200, but it is more in a rule based. And the right side second one represents the BES state of charge kilowatt hour. So actually AI returns more SOC. So actually SOC based, AI based algorithm results charging more EVs, more amount of EVs and power, whereas SOC lies below the AI. Then the aggregate EV charging. So here also the aggregate EV charging is more in AI and it is less in rule based. And finally, the cost, charging cost. So it includes everything. So the accumulation cost will be AI based concept returns less compared with rule based. The last one, you can see the PV power and the corresponding curtailment. So as I said already, the curtailment possible only using AI. So the blue color represents, shows the PV power in terms of kilowatt. So it will be, you can see at 12 o'clock it is maximum peak. So that time the maximum power available actually used to charge EVs and battery energy storage. So the grid requirement will be very less. So in order to make the grid more stable, the curtailment will be done at the grid side. So whatever the energy available supplied from the PV, the corresponding amount of power will be reduced to maintain the grid balance. So this is what's shown in the last graph. So this is for sample data, and I'm going to show you the sample EV BES data created on Excel CSV file. So we can load it. So either synthetic data or even if real-time data available, we can prepare this table. So with respect to our, it is actually represented from our 1 to 24, the PV available. So you can see the PV available will be maximum between 11 to 12. Then tariff. So noon only the tariff will be maximum high. Mostly that time only the grid will be loaded. Then this is the grid rule. Grid rule in the sense whenever grid free, we can load it. Whenever the grid under more stress, we must reduce. So that this is the grid rule. And this is the AA, that is from the AA point of view. Why? Because the AA consider the integration of renewable energy also. So it gives less stress when compared with the rule based. And similarly, SOC for rule based and the AA. And then EV power, that is EV charging for both. And finally, the curtailment. You can see the curtailment. This is the maximum amount of power that can be input to the grid so that we can reduce the curtailment. That is, we can reduce the power generated from the power stations. So this is the data set. I'm going to load it, and for this data set, I'm going to explain, see the result, and I'm going to explain. So you can use this option to load the file. So it is not running. You can refresh the page and you can upload the file. So for the new profile, you can see the difference. So the relationship among the, when compared with the previous one, are almost the same, but the profile is little different. So grid import you can see, A and grid based difference you can see. So amount of power import from the grid will be less and compared with the rule based. And here the battery energy storage system also fully charged by means of AI. This is the rate charge EV charging from aggregate and cumulative cost. So cost also gets reduced compared with the rule based. So with respect to the data what we have given, we can see that maximum 300 watts power available from the PV, and about nearly 50 watts is the curtailment power. So due to this PV power, we can save up to about nearly 50 watts power from the power generation towards the grid. So this is a simple program, right? AI program, and the help of the web page we can run it. So I will move to the next program. So here you can see the AI assisted renewable energy integration without battery energy storage. So without battery energy storage, so in this actually you can see the front end will be little different when compared with the previous program. So if we ask ChatGPT we can create a very good graphical user interface also. So we can plot various graphs and we can list the various parameters as a table. First, in this program, actually, these are the parameters given. First one is about the grid side. So number of charges, and then the port rating of the charges, then maximum feeder limits and PV capacity. Everything listed here. So all are customized inputs. From minimum to maximum, we can change its value. The second column, actually, the tariff and EV fleet mentioned here. So the peak energy price 12, or peak energy price 6. So the price ranges from 6 to 12. So if you prefer the energy rate 6, we can charge our vehicle at a low cost. We can save money. And EV sessions also given about 40 count, and energy per EV about 12.36. So minimum, that is the range, minimum 12 to 36 kilowatt hour. And the right side you can see third column, we can get the forecast data for 24 hours. And the price profile also given from 6 to 12. So you can see that it starts from hour 1 to 24. So in the morning, early morning, it will be very less cost, and in the noon it will be again 12, and in the night time also it is about 12. So with this data inputs, we can run the simulation, and we can find out the total energy delivered, grid energy, renewable share, cost, and peak grid power. So I'll run the inputs. So during each run, it will return a new results. 873, 940, 867, 885, 895, 848, 955, like that. So based on the data inputs, and during runtime, it will generate the results. So the first one shows the total energy delivered, especially for EV charging. Then the next one is grid energy, the amount of grid energy we consumed, and the renewable share is about 31.1%. Why? Because the remaining power is taken from the PV only. So that cost will be comes under the cost saving about 5,242. So as per the cost what we mentioned, the charging rate 6 is between 6 and 12, and peak grid power also it is reduced to 62.8 kilowatt. And these are all the graphical representation. The first one shows the power profile. So you can see the EV charging. So EV charging we cannot control, but we can change the we can forecast, and we can study the PV used and the grid input. So during morning hours, no grid power available till 6. Then it starts to the availability. So that but actually you can see the EV charging profile at 10 o'clock. You can see it will be almost 0, but in the morning you can see the EV charging. So this is actually nature of the curve. Similarly, during evening hours also. Why? Because morning and evening mostly we prefer to travel. So that time the charging will be almost nil. But in the remaining period, you can see it will be peak, and especially during the afternoon. So why? Because why we prefer afternoon? That time actually power available. The grid power availability is also more, and the PV power availability is also more. So that time we can prefer the EV to charge. Similarly, in the evening time. And price and demand. So the price actually even so again see actually in the noon time the PV power available will be maximum, but at the same time due to more charging, more EV users, again the tariff level will be more. It will vary from 6 to 12. So this is the detailed report from 0 to 23 or 1 to 24 hours. So total EV power taken and PV used, and then grid power input and the unserved power. So during this period, you can see power is at 6 o'clock, right? Unserved kilowatt about 60. You can see 12.9. So that we cannot avoid. Okay, so in this program, you can see actually we consider the renewable integration for EV charging. Similarly, in the next window, we just are going to see the including BESS, battery energy. So first, the concept behind BES. So whenever excess energy available from the PV, we can charge BESS. Similarly, whenever the lack of energy, when there is a need for additional energy and no PV is available, we can make use of it BES. Similarly, V2G also. There is no, technically there is no any big difference between BESS and V2G. Actually, BES mainly for storage purpose, and V2G also can be used in such a way to return power back to the grid. So it is similar to the previous program. The first column represents the grid parameters as well as the battery. So the number of charges, port rating, feeder limit given. The second one represents the data about BESS, then V2G. So if the energy battery SOC is about 50%, so it will recommend to perform the V2G. So less than 50% is not allowed. Then similarly, third column represents the tariff fleet and the different type of modes. Any mode we can select to run the algorithm and you can see the response. So this is baseline grid only, and this is V2G, and this is what model predictive control and reinforcement learning. This one offers the true optimization. So I'll run one by one. First, I'm going to select the baseline grid only. So for this input, we can see the inputs generated. So this is the inputs generated. The demand with respect to time interval, time profile. So we can run it. So in the baseline, it returns total energy delivered about 714.5 kilowatt hour total grid energy used. The remaining will be from the renewable sources and the corresponding cost and the peak grid. So whatever we discussed in the previous slide. So in the evening time, we can see the tariff price will be more. In the beginning level, actually, till 6 o'clock, the charging rate will be almost the same for 60 rupees. And this is the hourly schedule. So again, I'm going to run the V2G. So by considering V2G, with respect to the given data input, we can see the response. And finally, the MPC. So actually, we need to refresh the page to run each algorithm. So unlike other coding, we need to update the page. So whenever we try to select the new mode. So the input for all the three cases remains same. So here we can see it returns about 33% of renewable share, and the peak grid about 75.4 kilowatts, and the cost saving will be 4,465. So similarly, we can run, we can prefer any tool like actually MATLAB and Python is a dedicated tool. So the accuracy and run time, everything will be better. This is also another way of method to run the AI program, especially we can use it to solve the problem belongs to the EV. Madam, that's all, madam. Actually, I completed my presentation, madam. Do you have any doubts?
Participants, any queries, any doubts? Please ask to our resource person.
No doubt, ma'am. No doubt, sir.
Okay, sir.
Any comments, any feedbacks? Type in chat box also.
Ma'am, anything else, ma'am?
Nothing, sir. Nothing, sir. Thank you, sir. Thank you. Thank you for your wonderful presentation.
Thank you, ma'am.
Thank you, sir. Thank you, sir. Participants are requested to complete your online question, multiple choice question, and also complete your feedback link in ATAL portal as a participant link. After completion of feedback and question, question online test, we join at 7 p.m. 7 p.m. we join for validatory function of our FDP. So please all are requested to join in validatory function at 7 p.m. So until you complete your online test and also feedback.
Clearly give the instruction how to take up their test, because some people, they may not know. So you have to clearly give that instruction. They have to visit a ATAL portal to answer the MCQ question, right?
Yes, sir. Yes, sir. Yes, sir.
Mhm.
Please open your participation link in ATAL portal. Participants, in ATAL portal only, you put the feedback and also attend the online test.
See, parallelly you open another window, check it. If you have any doubt, please post your query here so that we can have a better clarity before moving on to the next session.
Yes, sir. Yes, sir. Thank you, sir.
Somebody has posted a message in the chat box, link not connected, like that.
Sir,
Yes, sir.
sir, in the ATAL portal, if I'm starting the test, it's showing that after 6, that is 18:30 only, it will be, we can take the assessment like that. It is showing, sir.
Ma'am, can you reschedule the timing? Can you check it, ma'am?
One second, sir, please.
If possible, you can reschedule the timing.
Okay, sir. Okay. Sir, now possible to read schedule, sir. As per ATAL FTP schedule only, I prefer the time 6:30 p.m., sir. 6:30
Okay,
to
after the,
feedback
yeah,
and
okay, ma'am.
online test. That is why I prefer the 6:30 p.m., sir. Still,
Okay.
not a reschedule, still
So
possible.
we can, so we
Not
can take it after 6:30 only.
Yes, sir. For online test, you start at 6:30 p.m., but feedback now only it's open.
So
Yes,
feedback,
ma'am. Yes, ma'am.
feedback link is
Uh,
open now. You can give your feedback, but you can
Yes,
take
sir.
MCQ test only by 6:30.
Yes, sir.
Okay.
Uh,
Okay.
right.
Thank you, sir.